Right now, as you're listening to this, America's massive $9.4 trillion labor market is undergoing a silent but honestly absolutely seismic shift.
Yeah, it really is. And it's happening right under our noses.
Exactly. And the wild part is, you might not even realize where the real fault lines are forming. I mean, we all see the daily headlines, right? AI is writing software code, it's generating these crazy award-winning images, it's helping kids with their homework.
Right, the flashy stuff.
Yeah, the highly visible consumer tech. But while we're all distracted by that, there's this much larger restructuring happening deep inside the walls of everyday companies. It is fundamentally altering how work gets done. And the traditional tools we use to measure economic health are, well, they're completely missing it.
They are entirely blind to it. I mean, we are essentially trying to navigate a 21st century intelligence revolution using mid-20th century yardsticks.
Wow.
The instruments are just not calibrated for what is actually happening on the ground right now.
Which brings us to the core of our source material for today's deep dive. We're looking at a truly groundbreaking research paper and a broader initiative called Project Iceberg.
Yes, Project Iceberg.
Right, and it produced something called the Iceberg Index, which measures skills-centered exposure in the AI economy. And this was put together by a huge powerhouse collaborative team, right?
Yeah.
We're talking MIT, Oak Ridge National Laboratory, and various state AI policy offices.
A really impressive group of researchers.
For sure. So our mission today is to explore how these researchers have built this revolutionary new way to measure where human skills and AI capabilities overlap. And crucially, they are doing it before the jobs are actually disrupted. It's like a literal roadmap to the future of work.
Exactly.
So, okay, let's unpack this. Why are our current economic tools, the ones we hear about on the news every night, basically blinding us to what's coming?
Well, it's because our traditional metrics, things like gross domestic product, per capita income, the unemployment rate, they're all lagging indicators.
Meaning they look backwards.
Right. They measure employment outcomes after the disruption has already swept through the system. So by the time, say, an administrative worker actually files for unemployment because their specific department was automated, the structural shift in the economy happened months or even years prior.
Oh, I see. It's the aftermath. You're basically measuring the smoke, not the fire.
That's a really good way to put it.
Yeah.
Historically, every major economic revolution has required us to invent a fundamentally new metric just to even understand what was happening.
Like what?
Well, during the industrial era, when we moved from farms to factories, economists had to invent the concept of output per hour,
Oh, sure.
just to measure physical productivity on an assembly line.
Yeah.
And then when the internet era arrived, traditional GDP couldn't capture the massive economic value of free digital services like search engines and email.
Right, because you don't pay for Google search.
Exactly. So the government actually had to create the digital economy satellite account.
So the obvious question is, what is the metric for the AI era? Like, what should we be measuring instead of just output?
The AI era requires a skills-centered measure. And the reason for that shift is really profound. For the first time in history, intelligence itself is becoming a shared input between humans and machines.
That is a wild thought.
It is. It's no longer just about a human operating a physical tool to produce an output. It's about looking at a process and asking, okay, which specific cognitive skills are being executed by the human and which are being executed by the algorithm?
And the data in this paper shows this isn't some far-off science fiction scenario where robots take over in 2050. It's happening right now. They point to real payroll data that is, frankly, a little terrifying if you're just stepping out of college and entering the workforce.
Yeah, the immediate impact is stark. The researchers looked at vast amounts of payroll data covering millions of workers, and they found a 13% relative decline in early career employment.
Wait, 13%?
Yeah, specifically ages 22 to 25 in AI-exposed occupations. What that tells us is that the corporate restructuring is already underway. Companies are adopting enterprise AI tools that handle entry-level, routine cognitive tasks. So their demand for junior employees to do the basic grunt work just drops significantly. Their hiring shifts heavily toward experienced, senior roles that require complex judgment, strategy, and oversight.
So basically, state and federal policymakers using standard unemployment data to plan for the AI transition is like driving a car down the highway by only looking in the rearview mirror.
Yes.
Like by the time you see the wreckage of the entry-level job market, you're already miles past the cause of the crash.
And the stakes of looking in that rearview mirror are enormous. Right now, governments are committing billions of dollars to infrastructure and workforce training programs. If they make those decisions based on lagging indicators, they're actively building training pipelines for skills that have already been technically displaced.
Which means by the time those students graduate, the tasks they train for might be entirely automated. That's rough.
It's a huge problem.
So if the old tools are just rearview mirrors, how did the Project Iceberg team build a forward-looking GPS? Reading through the methodology section of this paper, the sheer scale of what they attempted is just mind-boggling. I want to understand how this actually works. How do you map the future of the entire U.S. labor market?
Well, you can't just look at spreadsheets or, survey a few CEOs. They had to actually simulate the labor market from the ground up.
Okay.
They utilized the Frontier supercomputer at Oak Ridge National Laboratory, which, by the way, is currently the most powerful computer on the planet.
Unbelievable.
And with that computing power, they built what they call a large population model.
Okay, stop there. What does a large population model actually look like? Are we talking about a massive digital twin of the American workforce?
In essence, yes. They took vast amounts of demographic and labor data to simulate 151 million individual American workers.
151 million.
Yes, and they mapped those simulated workers across 923 different occupations and then distributed them across all 3,000 counties in the United States.
That is massive. But wait, if they just map 923 job titles, aren't they running into the same problem we talked about earlier? Like, a job title doesn't really tell you what a person actually does all day.
Exactly, and that is the brilliant pivot of this research. They didn't stop at job titles. They broke those 923 occupations down into over 32,000 distinct, specific skills.
Oh, wow.
Because jobs aren't monoliths. A job is really just a bundle of tasks and skills. So they took the human side of the equation and basically dismantled it into 32,000 components.
Okay, so they have this incredibly granular map of human capability, things like drafting a memo or reconciling a ledger or analyzing a blood sample.
Yes.
How do they measure the AI against that?
They cataloged over 13,000 actual production-ready AI tools. And we aren't just talking about consumer tools like ChatGPT here.
Right, the stuff everyone knows.
We're talking about highly specialized enterprise workflow systems, financial co-pilots, automated HR compliance software. They map the capabilities of those 13,000 tools against the exact same 32,000 skill taxonomy.
So it's like a mathematical matching process. They can take a specific human skill, say verifying compliance documents, and the supercomputer scans the 13,000 AI tools to see if there is a software architecture currently on the market built specifically to parse and verify documents.
You have it exactly. It is a massive virtual collision course. It shows exactly where the technical capability of a machine perfectly overlaps with the required skill of a human worker.
That's fascinating.
And the researchers didn't just build this in a vacuum. They rigorously validated it against real-world data. When they tested this skill mapping theory against what actually happened in the labor market, it successfully predicted 85% of real-world career transitions.
Wait, I need to push back on this for a second. With that level of precision, predicting career transitions at 85%, isn't this just a supercomputer generating a massive hit list of who's going to get fired next year?
Well,
Because assuming that a company will automatically deploy a tool just because it exists feels like a leap. Businesses are messy. Software integration is hard.
no, this raises a really important question, and it is a vital distinction the researchers make in the paper. The Iceberg Index does not predict job losses. It absolutely does not predict when someone will be fired. What it measures is technical exposure.
Meaning it measures the raw overlap in capability, completely independent of whether a CEO has the budget to actually buy the software or the competence to successfully integrate it.
Right. Think of the Iceberg Index like a massive earthquake risk map. A geological survey can tell you exactly where the fault lines are across a continent, right?
Sure.
It can measure how much pressure is building up beneath the surface. It shows you the structural vulnerability of the terrain. But that map cannot tell you if the earthquake will strike on a Tuesday at 4 p.m.
Right.
or if the buildings above the fault line are reinforced enough to survive the shaking. In the labor market, this map shows where roles are highly likely to be restructured because the underlying tasks can now be technically performed by machines. It reveals the fault lines. It does not predict the timeline.
Okay, here's where it gets really interesting. Because when they actually turned the supercomputer on, ran the simulation, and mapped all the fault lines, it revealed this massive optical illusion in how we currently view the labor market. The entire index is split into two parts, right? The visible tip of the iceberg and the hidden mass below the waterline.
Yes.
Let's talk about the tip first.
So the researchers call the tip the surface index. This represents the highly visible technology disruption we read about every single day. This is AI disrupting computing, software engineering, and basic coding.
The stuff that generates panic on social media, like projections of over 100,000 tech job losses in 2025, reports that AI systems are now writing over 1 billion lines of code a day, outpacing human developers.
Exactly.
It feels like the entire economy is shifting right there.
It feels massive because it's loud. But the supercomputer simulation revealed that this visible disruption, the surface index, only represents 2.2% of the labor market's total wage value.
Wait, only 2.2%.
Yep. That is about $211 billion.
Metcalf.
And geographically, it is highly, highly concentrated in your classic coastal tech hubs, places like Washington State, which leads the nation with 4.2% exposure, along with Virginia and California.
2.2%. That is a tiny fraction of the economy compared to the cultural panic it generates. So if the tech industry is just the tip of the iceberg, what did the simulation find lurking beneath the waterline?
The hidden mass. The researchers calculated the full Iceberg Index, looking beyond software engineering and focusing heavily on cognitive automation. They found that AI's technical capability to automate tasks extends incredibly deep into administrative, financial, and professional services.
And what's the actual scale of that hidden mass?
It represents 11.7% of the labor market.
Wow.
That equates to approximately $1.2 trillion in wage value. It is more than 5 times larger than the visible tech disruption.
5 times larger. I want you, the listener, to just pause and think about your own workplace right now. We aren't just talking about your IT department or the web developers. Think about the HR team processing onboarding documents and benefits enrollment. Think about the financial analysts compiling quarterly revenue reports, the administrative coordinators managing logistics, schedules, and vendor contracts. That $1.2 trillion of wage value, that is where the quiet revolution is actually taking place. It's the everyday, cognitive, white-collar work.
And this hidden mass is crucial because it completely upends our assumptions about geography. Since this vulnerability is so heavily weighted toward administrative and financial tasks, it completely flips our traditional understanding of where the risk is concentrated.
The geographic flip. I have to admit, reading this part of the study blew my mind, because if you ask anyone on the street, they think AI risk is fundamentally a Silicon Valley problem.
Right. But the data shows the exact opposite. The Iceberg Index is widely distributed. In fact, states like Delaware and South Dakota show significantly higher overall Iceberg Index values than California.
See, that sounds absurd at first glance. Why are Delaware and South Dakota sitting on larger AI fault lines than the tech capital of the world?
Well, you have to look at their economies through the lens of skills, not tech companies.
Oh.
South Dakota, for example, is a massive hub for credit card processing and financial back-office operations.
Oh, right.
And Delaware is the corporate registration capital of the world, teeming with legal, compliance, and administrative processing centers. When you measure exposure by specific cognitive tasks, a massive back-office financial processing center in Sioux Falls has a vastly higher concentration of automatable skills like data entry, risk calculation, and document verification than a diversified tech hub in San Francisco.
Which brings us to a phenomenon the researchers call the automation surprise, and this is aimed right at America's industrial heartland. States like Ohio, Michigan, and Tennessee. Traditionally, these states are bracing for physical automation, right? They are deeply worried about robotics replacing humans on the factory floor.
Yes, the classic narrative.
But according to this data, they are completely missing the massive wave of white-collar automation heading straight for them.
Let's look closely at Tennessee as a prime example of this blind spot. If a state planner in Tennessee only looks at the surface index, their visible tech sector, their exposure is tiny, just 1.3%. A policymaker might look at that and think, we are a manufacturing and logistics state. We don't have a massive software industry. The AI disruption isn't going to hit us hard right now.
But then you pull up their actual Iceberg Index.
And it sits at a massive 11.6%.
That's a huge jump.
It is. If we connect this to the bigger picture, it makes perfect sense. Every physical factory, every supply chain, every massive logistics hub in Tennessee is supported by a sprawling infrastructure of administrative, financial, and service functions. You can't run a global supply chain without an army of coordinators, accountants, and compliance officers. Those white-collar support roles have up to 10 times greater technical exposure to AI than the state's actual visible tech sector.
So you could have policymakers in the Rust Belt entirely caught off guard. They are standing on the factory floor, watching the assembly line, feeling a false sense of security, while the back office, the administrative engine running the factory, is quietly sitting on a massive fault line.
Exactly. And the supercomputer simulation highlighted another critical dynamic. Even if two different states have the exact same high level of overall exposure on the Iceberg Index, they might have to manage that risk in completely different ways, depending on how that exposure is structured.
This is the idea of concentration versus distribution. The researchers mapped this using something called the Herfindahl-Hirschman Index, or HHI.
Right, the HHI is a classic metric in economics. It's usually used to measure market monopoly and concentration. But here, the researchers brilliantly adapted it to measure whether a state's AI exposure is clumped tightly into one or two dominant industries, or if it is spread thinly across the entire economy.
The paper draws a fascinating contrast between the Northeast Corridor and the manufacturing belt. To visualize this, let's look at three states: Virginia, Iowa, and Ohio. Their overall AI exposure numbers are nearly identical. Virginia is sitting at 12.48%, Iowa is at 12.22%, and Ohio is at 11.34%. On paper, it's basically the exact same level of risk.
But the internal structure of that risk, the HHI score, is radically different. Virginia has a highly concentrated score. Their AI exposure is densely packed into just two main sectors, finance and technology. Iowa and Ohio, on the other hand, have highly distributed HHI scores. Their 12% risk is a thin layer spread across almost every single sector in the state: logistics, agriculture, production, administration, healthcare services.
To put an analogy to this, imagine you are tasked with carrying 50 pounds. Virginia is carrying a 50-pound boulder. It is incredibly heavy, it is difficult to manage, but it is one distinct solid object. You know exactly how to hold it, and you can build a very specific cart just to move that boulder. But Iowa and Ohio, they are carrying 50 pounds of loose sand scattered inside a massive multi-pocketed backpack. It is the exact same amount of weight, but it shifts constantly and it touches every single part of your body.
That is the perfect way to understand the policy challenge. Concentrated risk, the boulder, allows for targeted, sector-specific action. If you are the governor of Virginia, you can sit down in a room with the leaders of the finance and tech industries and hammer out a focused transition and retraining plan. The problem is isolated.
Makes sense.
But distributed risk, the sand, demands massive, multi-sector coordination. In Iowa, you can't just talk to the tech sector. You have to coordinate policy across manufacturing, retail, farming, and logistics simultaneously, because the cognitive administrative tasks being automated are woven invisibly through all of those industries.
Which really highlights the ultimate proof of why this Project Iceberg research is so vital, and why those old economic tools we talked about at the beginning are actively failing us.
Yeah, the researchers ran one final definitive test. They took the traditional metrics, GDP, per capita income, and the unemployment rate, and mathematically mapped them against the new Iceberg Index. They wanted to see if the old tools could accurately predict the new skills-based risks.
And what happened?
Complete failure across the board. GDP, income, and unemployment explain less than 5% of the variation in skills-based exposure.
Wow.
In some cases, the correlations were actually weakly negative.
Less than 5%. So what does this all mean? How can a metric as foundational as GDP fail to capture a $1.2 trillion structural shift?
Because GDP measures output, and AI might actually increase a state's overall economic output while simultaneously restructuring the entire labor force underneath it. If a governor or a corporate CEO is looking at a high GDP and a low unemployment rate and thinking, hey, our workforce is thriving, we are safe from AI, well, they're mathematically incorrect.
So the numbers look good, but the foundation is shifting.
Exactly. A booming economy can easily hide massive, localized skill displacement. The old metrics measure the economy of yesterday. They simply cannot see the $1.2 trillion of cognitive skills that overlap with AI capabilities today.
The big takeaway here for every single person listening is that we have to fundamentally change our vocabulary. We must stop looking at job titles and start looking at skills. AI isn't necessarily coming for your job as a holistic single concept. It is coming for specific tasks within that job.
Take the financial analyst we mentioned earlier. An AI tool is not going to eliminate the need for complex financial strategy or client negotiation. But if an enterprise AI can instantly process thousands of pages of compliance documents, extract the relevant data, and run routine historical analysis,
Which is stuff that used to take the human analyst 3 full days a week.
right, then the fundamental nature of that job changes.
The title on the business card stays exactly the same, but the skills that make you valuable to the company completely flip. Your value is no longer in your ability to extract data. Your value is in your ability to interpret the AI's output, manage the overarching strategy, and communicate the nuance to human stakeholders.
And that is why the Iceberg Index is such a critical breakthrough. By revealing the fault lines before the earthquake strikes, it allows governments, businesses, and individual workers to see those specific skill shifts coming. It means a company can proactively retrain that financial analyst to focus on higher-level strategy now, rather than waiting for them to become obsolete because their only specialized skill was data extraction.
It changes the whole narrative. It moves us away from this doom loop of predicting job losses and shifts the focus to mapping capability shifts. It gives us a chance to actually prepare.
So, okay, let's wrap up this incredible scope of Project Iceberg. We've gone from the massive frontier supercomputer simulating 151 million workers down to the skill level, past the highly visible tip of the tech industry, and plunged deep into the hidden $1.2 trillion mass of cognitive automation. We've seen how Rust Belt states face hidden white-collar surprises, and how carrying a boulder of concentrated risk requires a totally different strategy than carrying a backpack of distributed sand.
What's fascinating here is that this isn't just about macro-level economic policy. It is highly personal. Knowledge is most valuable when it is applied. I would urge everyone listening to look at their own daily routine this week through the lens of the Iceberg Index. Break your own job down into a bundle of skills. Which of your tasks are routine, repeatable cognitive processes and which require complex, uniquely human judgment? Understanding that overlap is where your future value lies. I love that. And I'll leave you with a final thought to ponder on your own, building right off that idea. If the Iceberg Index proves that AI can technically perform massive swaths of our cognitive, analytical, and administrative skills, what happens when human soft skills like deep empathy, complex ethical judgment, and genuine human connection become the primary, scarce currency of the labor market? As the seismic shift continues along these fault lines, will we see the creation of entirely new, highly paid, human-first job categories that we don't even have the vocabulary for today? Something to think about as you navigate the hidden layers of the new economy. Thanks for diving deep with us.